All right, everybody, welcome. Welcome. This is Drew Jones with Climate Interactive, and I'm here with Ava De Leon and our colleague, Peter Croce. We're thrilled that you're here for this webinar. We're going to be looking at En-ROADS, the En-ROADS Climate Workshop, and three brand new features that we're particularly excited about. It's going to be focused on nutrients, on malaria and dengue, and also on drought. So welcome. And as people get oriented, please go to our poll. Open up another browser window and you can see the address. Ava, would you put that in the chat? Look to the chat there and you'll see pollev.com climate inter 935. So if you would put that in, go to the poll and answer this question. What is a climate impact you've experienced and where? We're going to get grounded on why we want to work hard to prevent this challenge. And here is an opportunity to share something that you've seen in the real world. Fires in Colorado in the US. Thank you. Flooding. Uh, Flooding. We had flooding in Kentucky near here where I am in North Carolina in the US. Polar vortex this month in Ohio, a heat wave in India, drought in the Midwest, extreme heat. Yes, more extreme heat. Canadian wildfires impacting air quality. So you've really seen this in different places yourselves. Warm winters, little snow in the northern US, fires in North Carolina, and Hurricane Helene here in Asheville. I was there for that as well a couple months ago. Still recovering, and our economy will be down for a good bit of time. Heat stress and flooding, fire, impacts on floods and flooding, extreme precipitation events, heat dome in uh, in the Pacific Northwest, wildfires in New Jersey and Pennsylvania in the US. This rarely happens, but it did last year. Okay, you're seeing these things. Uh, you're seeing them. Okay, we want to address these challenges. And what we see around the world is that top decision makers somehow struggle to take effective action on addressing climate change. They lack clarity about the solutions, how big the solutions could be, how much of an impact they could make, but also what are the costs of inaction. The good news is that research is out there. Research exists, but our colleague at MIT said it really well. Research shows that showing people research doesn't work. Research shows that showing people research doesn't work. That's why we're here at Climate Interactive. That's why our colleagues at Probable Futures, who added a map to En-ROADS recently, and you'll see today, are here to engage people in a different way, to help them learn on their own terms and see better futures, both to prevent climate change and also to adapt to what's coming no matter what. The way it works so well with us is fast running simulations. And today we're going to show you En-ROADS. Here it is. Why do we have 1.5 million users in the world? Because it runs so fast. Because it runs like that, immediately you can see the results of your actions and you can see vivid outputs like what Peter's going to show us later regarding the likelihood of prolonged drought. But I'm not going to show you too much in that yet. In the poll land, and I'm going to go back there, I'm curious, see how much I should share of this, of the simulator. Have you seen a presentation, or go back to the poll if you would. Have you seen a presentation? And we have ambassadors, people who have gone through and watched our 63 5 to 10 minute videos to teach them how to become a facilitator of an En-ROADS experience. You're in 84 countries. There are 863 of you right now. Go to chat, and I'll see if you're actually doing this, and introduce yourself. You might be in some place where one of these ambassadors lives. In Minnesota, Fred Rose, and in Boston area, Tamara Ledley. You've run so many sessions Don Scholl in Minnesota. So if you're one of those people, introduce yourselves there in the chat so people could find you. So what are we seeing? Have you seen this before? 73% yes, 27% no. All right, that's a little more no's. People who are new to this, it's really good to see some new folks joining this work. So I'm going to take a step back, give you a little bit of a background of who we are and what we're up to. Here it is. Okay, we are Climate Interactive, not-for-profit climate tech company. We work closely with MIT Sloan's Climate Pathways project to get our simulators out to the hands of decision makers. In fact, 128 members of Congress met with us in the US before the passage of the historic IRA bill. We're funded by this group of funders, and particularly this work that we're showing you today was funded by Wellcome Trust in the UK for a lot of the health funding that we've done. I talked about impacts around the world. You've seen many. The most current ones we see nearby us in Kentucky, flooding there. But there's always something on the other side of the world, and really it's been Indonesia lately. What we do, as we said, top decision makers need experiences of seeing better futures. What are the actions that can be taken? And so just this year, by giving the simulator away, here's some pictures of people. This is Hiske in Amsterdam with the group. They made a 2-degree scenario behind them. Here in Kazakhstan, students doing something. She's doing something with 3 with her fingers. I don't know what that is, but there's a group in Kazakhstan. In Italy, you can see behind them GDP per capita graph, greenhouse gas emissions. And over here, you can see to the side, this is clearly they're doing the international negotiation because these are contributions to the climate fund over here. Marta Torin at Appalachian State University here in North Carolina near me. In Italy, the game version, we made this into a role-playing game that we played with students, we played with businesses, people around the world. Jaime Mata in Spain, here's a group there. And then some folks on LinkedIn just posting around the world, people running the game here in the Philippines, here at EESI. And in fact, I'm going Sunday night to Washington, D.C. to give a presentation here to staff members for U.S. Congress people. There's actually a study that was done about the workshops led by Juliet Rooney Varga at UMass Lowell, and she found that after the workshop you're about to do, 50% were convinced to take a new action, and then 75% of those people actually did. That's the dream we have here of this. Today, we have a special focus, which is these 3 new features. And one of them involves our partner at Probable Futures. So I want to introduce Peter Croce, Probable Futures, who did a lot of the engineering behind the map. You're going to see, maybe Peter, say a little bit about what Probable Futures is.
Hi, everyone. I'm Peter Croce. I'm Director of Product at Probable Futures. And Probable Futures is a nonprofit climate literacy initiative. So what does that mean, climate literacy? So we focus on helping people understand what it has meant to live in a stable climate in the past. And so we help with really anchoring in what have we built within the world that is dependent on a stable climate. And then the next step is saying, okay, now that we understand what depends on a stable climate, how can we understand what is changing? And therefore, how can we adapt and find ways to live well in that changing climate? And so Drew's showing some of these maps that we have. We have educational materials in the climate handbook on the top of the navigation of this page. That is a great place to start. And then after really understanding those fundamentals, you can explore these maps and you can begin to see all of these different changes. We have 30 plus maps covering conditions like wildfire, drought, precipitation, heat and humidity combinations. And all of these things underpin assumptions that are built into our daily life the ways that we live, the food that we eat, where we get our water, all of these are dependent on the climate in some way. And so when we begin to uncover these assumptions, we can find ways to adapt and live well in a changing climate.
Cool. Thank you, Peter. And we're going to see one of his maps in En-ROADS a little bit later. So let's dive into this issue. Go to your poll, answer this question. I am blank about climate change. If you see a word that you like, write it again, it'll get bigger. If you have two words, put a hyphen between them, and then they'll stay together. Terrified, despondent, concerned, worried, sad, concerned, panicked, distraught, inspired, sad, terrified, distraught, heartbroken. Yeah, I hear you. One note, facilitators, make space for people to talk about how they feel about this. That's the only way that people's brains can relax enough to think creatively about solutions. We have to give space for heart as we engage people in thinking about solutions. This is a group that's concerned. I hear you. Keep voting, keep adding your thoughts here. Okay, hurt, concerned, worried, angry. Angry just got bigger. Oh, here come the angry. That's uh I hear you. Wow. So many big feelings. Thank you. So given all of that, um, let's talk about some of the impacts that you really might be most concerned about. And we're going to really focus on three. And the first one is going to be drought. Where have you experienced or learned about drought, and what were the effects of it? Where have you seen this in the world? And by the way, if you have a question along the way, go into Zoom Q&A. You hit the button that says Q&A. Ava's going to answer a lot of your questions, and later Peter's going to answer some of your questions if they're about drought. And Southern California, California, past summer here in New Jersey, having to conserve water in California. Southeast Brazil, Sao Paulo. Poor crops. Boy, a lot of people in California today. Absolutely. Drought in the Midwest. So we're looking Brazil, California, New Hampshire, India. My country lost $20 million in crops due to drought. At home, Tucson, Arizona, trees dying, mountain fires. Northern Iowa, reduced yields. Arizona, California, permaculture class in my normally moist New England town. Okay, what do? We go look and see what we can learn about this. And because of our partnership with Peter, we've now been able to add a new feature. So when you go to En-ROADS, and Ava, would you post the link so everyone can go in and play? Here's En-ROADS. It's choose your language. It's in 20 of them right now. Go into here under impacts. You're going to see drought, but also a whole range of issues. The first place to connect with people is don't go straight to how do we get to 2 degrees? Don't start talking about electrification. Talk about what matters, where it matters to people. In the atmosphere, here are some that you can look at on heat, different ways, different types of heat, deaths from heat, outdoor labor losses, and population exposed to hurricanes and typhoons, like in Kentucky, population exposed to river flooding, air pollution, malaria. Well, we're going to get to these later. Crop nutrients, we'll get to that later. But down here, ecosystems and biodiversity, likelihood of prolonged drought. So some of the places that were mentioned, I heard someone say Sao Paulo, Brazil. So there's a search. You can go search there. Make it really big so you can see it well. See, where are we? This is the southern area. And what you're looking at is an area in 2100 at 3.3 degrees. If we do very little to prevent climate change, then we see that it's yellow and green. Yellow, you explained to me, especially Peter, you're the king of this stuff. Explain to everybody what yellow and green is and what it's saying about 2100 there.
Yeah, so we're seeing some likelihoods here. So probability of an extreme drought. Actually, this is just a normal drought
Moderate.
lasting 12 plus months. And so that yellow color there, where it says 34% to 50%, you can think of 33% or so as being about once in every 3 years on average. So if a place has a 33% chance of drought, then about every 3 years, you can expect that long period of drought. If you look to the north, I saw some places that were orange, and those places are showing over 50% chance of drought. In that case, if it's 50%, then you could expect on average a long drought like this about one in every 2 years on average. And if it's more than that, then really you need to start thinking about drought as a changing regime in that place, where no longer is it that the norm is the non-drought condition. It is actually becoming that the norm is the drought condition. And so that could be described as aridification.
And when you squint your eyes at the big picture, we can see some of those orange and red areas as where it's becoming a chronic condition. And you talked about arid land conditions, and one place to connect this map would be some of those calculations that we made of how much arid land, desertification is one of the examples of this, should we expect to see in the world? And we see it rising up over time uh, towards the area of the Sahara Desert being added. Now, one note you're looking at right now, this is a future that's not going to happen. So let's uh, hold it lightly. Uh, this exercise is going to be in about preventing this upper end of warming that leads to that kind of drought prevalence and arid land expansion. Okay, that was one. Two others that we've just added, and for all of you longtime users, you're going to find when you scroll down here, a second one is malaria and dengue, additional exposure from warming. 2000 to 2100, exposure per 100,000 people. So this isn't total number of people. It isn't growing because population is growing. That's what that means on the left. Instead, it's people added on top of the numbers of people who are already exposed to dengue and to malaria. Both of them are serious diseases that, well, can lead to death. One way to learn about them, when you see a graph like this, go to this little triangle, click on it, and you'll get some important information added. The big news on this is it's already really high. A lot of people experience exposure to dengue, malaria. One of my close friends here, North Carolina, went down to Costa Rica. He caught it, dengue. It's all over. 70,000 per 100,000 for malaria, 65 for dengue. So it's already high, but it could get a lot higher. To learn more, go down here in this to read more. Overview of malaria and dengue, big messages, etc. Ava, would you post this and actually the link to the description of the drought map as well? This is in our help section, FAQs. More additional information to uh, expand on what we're saying here, what the key messages are, and interesting things like where we expect to see malaria and dengue in the world. Okay, that's the second, the big message. Can we do better? Can we do better than this? And then the third, this one really surprised me. I'm just going to ask you about this one to see what your existing understanding of this issue is, because I was so surprised by the report from our technical team when they came back with this one. So I want to ask you, do you think that many people who are concerned about climate change understand that it will affect the level of nutrients in food, protein, iron, and zinc. Did people know this? That climate change would affect the level of nutrients. If you agree, then you're at the bottom. A, which most of you were voting, actually, no, don't, most people don't know this. I didn't know this. I've been working on climate change for 25 years. I did not know this. This was a big surprise to me. You agree with me. I didn't know it. Oh, that's the same question. So if you did know it, how? What is the mechanism by which climate change would affect nutrients? What do you think would be going on? Why would there be less protein, iron, and zinc? And these are things that, if in diets, lead to stunted growth, susceptibility to disease, anemia, degradation of soil. Soil. I don't know. It's too specific. Yeah, I didn't know either. Something about the equilibrium. Lower nutritional values, that's the fact. But how? Like, why? What is it about climate change that is leading to lower nutritional values of food? What is it about it? And there was a really good study I'll show you in a minute where we got the information. But what is it about it? And I ask this because when you engage other people with this tool, it's important, well, to often, yeah, to help people understand a level deeper about what's going on. Maybe plant stress because of heat, perhaps. Plants will start to select for different traits to combat drought. Oh, because there's drought going on. And so they're like, let's do this to deal with drought instead of having these protein, zinc, and iron, more stress on the plant. Sale changes in soil microorganisms. I haven't seen the answer yet. I haven't seen the answer yet. So this is good. It's good that you're here on a webinar to learn about this. Lack of water in soil? No. Okay, here's the study. Let's go look at it. Here it comes. We'll pull up this impact, and it is crop nutrient decrease. And whenever you have a question about it, go look at the study. Uh, Here's one of the studies. Rising atmospheric CO2 is reducing the protein concentration of a floral pollen source essential for North American bees. This is one of the studies. That's just a very specific one. More broadly, increasing CO2 threatens human nutrition. I think this is the main study. The point, though, and the answer is in the title here. It is in the title, CO2 concentration. Scientists took a bunch of plants, maize, wheat, rice, soybeans, put it in, like a greenhouse covered area, pumped a lot of carbon dioxide in, and they found that with the extra CO2, you get more growth, faster growth with elevated concentration of CO2. Carbon dioxide is plant food, right? However, you get more growth, but less nutrients in it, less protein, zinc, and iron. And the scale is big enough to matter. This gray line is where it is today. It's already dropped 1.1% a year. 1.1%, not a year. Wheat, 2.7, rice, almost 2, soybeans, almost 2. But it could go up to 4.8, 11, 7.7, 8.8. The point of this, again, we want to do better than this. It complements another graph that you may have seen, another bar graph, which is crop yield decrease. This is crops basically, well, yielding less maize, wheat, rice, and soybeans because of the temperature. So this is the dual effect of climate. Elevated concentrations of CO2 as pollution, and then trapping heat, warming the earth, and that's changing crop yields. So two effects. We want to do much better. Okay. I bet there are questions coming into Q&A. Write your questions into Q&A, and at the top of the hour, we're going to answer more of them live. So, three big impacts. We want to do better. How can we do better? Let's go try a bunch of new things. Actions to prevent climate change in the mitigation area. So start thinking down here about all these levers. Which would you want to pull? We're going to pull levers and see effects in the context of this baseline scenario. In this baseline scenario, we're not taking much additional action. Current policies are in place. They don't strengthen. Coal continues. See, 20 out to 2100. That's the brown area. Stacked on top, oil. Stacked on top, natural gas. Renewables. See that green wedge as wind and solar grow? Bioenergy, burning trees and plants for energy. And then on top of it, nuclear. This is the baseline we're dealing with. We also have other gases. The biggest that matter is methane. Methane from energy, on top of it from agriculture, on top of it from waste. But then we have others, and I'll show you the total greenhouse gases. I showed you just now fossil fuel CO2, coal, oil, and gas, bioenergy. Oh, bioenergy is in the green, actually, and deforestation is in the green, land use CO2. F gases, fluorinated gases, HFCs in your refrigerators and things like that. Methane, I showed you a minute ago and broke it into 3 areas, and nitrous oxide. This is all the pollution. The challenge that you have in the next poll is how do we get that to come down, to have temperature come down so that we can address nutrition, dengue and malaria, and drought. We'll come back to those and see how much better we do. So back to your poll. How are we going to do it? Open up the poll and what do you like? What shall we do? Encourage renewables, nuclear, energy efficiency, food, transport, reduce deforestation. What do you like? Carbon price, renewable energy. Carbon price, renewable energy, phase out fossil fuels, energy efficiency. What are we doing here? You're creating a vision. We talk so much about how bad it's going to get and how we're going into the wind in so many ways. This is a time to talk about what we want. What do you dream of? This is the golfer Tiger Woods visualizing his golf swing 1,000 times before he does it. Visualize what you want to see. Put it into a poll. Tell me that you want a carbon price. Tell me that you want renewable energy and energy efficiency and phasing out fossil fuels and deforestation and forest degradation. Fantastic. Let's see how much they help. We go back to the simulator and I'm going to hit this little reset and make it nice and big. Let's try some stuff. The thing that you mentioned the most was carbon pricing. This is a tax that gets laid on coal, oil, and gas. It would show up in electricity prices. It would show up in whether a oil refiner is going to be built because suddenly it's more expensive to process that oil because of this tax. It's going to affect natural gas around the world. Right now, 5% of the world's emissions, excuse me, right now we have a carbon price of $5 because 25% of global emissions are covered by a carbon price. And $20 is that average price. 20 times 0.25 gives you $5 a ton around the world. Let's increase it. But before I increase it, what do you think that temperature will go down to? The goal for temperature is to get well below 2 degrees. Here's the temperature going up. We sit here around 1.3. Some people say we've crossed 1.5. We're in this zone right here. We want to stay below 1.5. We want to stay below 2. How much do you think a $100 a ton carbon price would help? How much will it bend that curve? So think in your head, say a number to yourself, and then here it comes. 2.7. Did it save the world? No. Did it help? Yes. How much? A lot. That's a lot. That's a lot. Something that can reduce temperature 0.6 degrees. What did that get? A third of the way to 2 degrees, a quarter of the way to 1.5 by the end of the century. That helps a lot. Why? The big reason it helps a lot is that it keeps us from burning coal. It keeps us from burning oil. Not quite as much. Coal is more sensitive because it's more carbon dense. And it keeps us from burning natural gas. And those are the three big causes of climate change: burning coal, oil, and gas. So directly and soon, it doesn't wait to the 2040s. It very quickly reduces those emissions. What does it do to energy demand? Kind of surprised the first time I saw this. Total prime energy demand is lower. Why? When you price carbon, the overall price of energy, cost of energy goes up. This is an equity challenge. However, it leads to more energy efficiency and conservation. When people spend more money on energy, they use less of it. So, what a big contribution it made. Second thing that you voted for, many of you said renewables. Well, what did we just do to renewables? We indirectly really boosted them a good bit. Why? Because we taxed their competition. They're thrilled by this. If we also boosted them with subsidies, and if we get fortunate and have R&D to get more storage, we need more storage because renewables are variable. That boosts renewables more, and temperature actually did come down a little bit more. What else? Phasing out fossil fuels. Now, it does a lot on its own, but in this context, I think we already still have some coal that lives out throughout the century. What if we phased out more fossil fuels like coal? Underneath here, like you click on these three dots, you can change many other sliders. Renews coal infrastructure. Watch this. Boom, it goes away, comes down a little bit more. But what we really need to do is the same with natural gas. Look over on the right, phasing it out, and oil as well. And put all three together, 2.5 degrees. You also voted, a lot of you, for energy efficiency. This could do a lot as well. I'm going to go back here and see what happens with energy efficiency. What am I going to look at with this? We've already reduced energy demand a good bit. Let's go see. Did we? Total primary energy. Well, let's just look at greenhouse gas emissions. It helps as well. Energy efficiency and in transport. Notice we don't need as much energy overall. I'm going to undo those two moves. Watch it go back, 2 steps back and back. And then we do it again. Energy efficiency in buildings and industry and in energy efficiency in transport. We just don't need as much energy nor as much wind and solar, which is good. 2.3 degrees. Electrification can complement a lot of this. Now, it didn't do a lot that you saw there because we already had a carbon price. Anything that takes out coal, oil, and gas, that will reduce emissions and temperature. All of these energy actions are not enough. We're still heading at 2.3 degrees. This is why, well, things like methane really matter. Look at methane. We saw it before. You may remember the blue area was bigger, energy production methane. Why do we have less methane coming from energy? Think for a second. Well, what's happening to the sources of energy production methane? And that's coming from natural gas, which some call methane gas because it's mostly made of methane, coal, and oil. Less coal, oil, and natural gas, less methane. But we haven't touched the big yellow area of agricultural emissions, nor of waste. So under here, we can change diets, food from animals. We're headed towards 30% food from animals. What if there's less? Boom, a little less. Food waste, a lot less emissions of methane. And then best practices of handling manure better, of taking care of cows better, which reduces their emissions. And then that reduces the yellow area. Waste and leakage similarly. And then we're down to 1.8. We may have carbon removal in nature, in agricultural soil carbon. Maybe people will plant trees, but it takes a lot of land to plant enough trees to matter and it takes a long time. Maybe some technological carbon removal, 1.7. Okay, I just put in a lot of the actions that you proposed, and now we have a scenario that doesn't have emissions going up and up, but falling rapidly. By the way, that's the mission of Climate Interactive, greenhouse gas emissions falling rapidly with equitable policies. How much better do we do? How much better will we do? Okay, Peter, let's go back and see when we simulate through probable futures the likelihood of prolonged drought in this better world. There is not nearly as much red. You click this button, show baseline. Here's baseline and then this scenario. We can see how much pain and suffering we've avoided. And I'm going to go down here to where we were in Sao Paulo, weren't we? We were right there. So here, this Sao Paulo area is all green. In the baseline, well, we've moved from categories in this, at least the eastern area, from 1 in 3 years or 1 in 2 years down to 1 in 10 or 1 to 3, as Peter was interpreting it. So baseline, better. Worse, better. And then it's particularly distinct north of there in the Amazon. Look at this. The from red down to orange. Again, moved another category down. A better
Yeah,
world. Anything you would add, any caveats on that one, Peter, or did I say that right?
no, that's very well said. And these areas, especially when we're thinking about those really high percentages, those reds, and we're thinking about desertification, those areas that are forested now, that are rainforests, would be facing situations of like transitioning to a savanna, like changing the actual the ecosystem could really change dramatically if there were prolonged droughts that became the norm. And so
Yeah.
that is a really, really important thing to avoid. And another thing I would add here is that even if we slow the time before which we reach some of these temperatures, that would also be very, very good because that would allow ecosystems and people time to adapt.
Well said. Thank you. And Peter was referring to that next causal effect of the drought, which is ecosystem shifts. How many million hectares are moving? In this case, it gives an example here that's helpful. From boreal evergreen to temperate coniferous rainforest, or he mentioned from rainforest to savanna. These are the numbers of millions of hectares. This is all that gets avoided when we get on track to a 1.7-degree future. Okay, drought. Let's go look at some of the others that we were curious about. Malaria and dengue additional exposure. So we really bend the curve on this, and particularly out in the 2040s. The bad news is that we get the same 15 years. That's because this is dependent on temperature, and the temperature has so much momentum in it. It's difficult. It turns like an ocean liner, not a sports car. So we really are looking at the temperature rising for this next 15 years, then bending over. The results we'll see now over here for crop nutrients. Remember, we looked at this one because of CO2 concentration. Maize, not 4.8, but it's actually improved a little bit relative to today. Today we're at 1.1. This would go down to 1.87. 2.7 goes down to 2.1. Notice how much we can prevent when it comes to those nutrient losses because of the rising CO2 concentration. I'll pull that up again. That, and you can see it's getting better because concentration peaks and then it actually begins to fall. Concentration begins to fall. And that means there's less CO2 in the atmosphere. It's like taking a blanket off of a bed when you're lying there in the summer with 5 blankets. You take off a couple blankets. That's what it means to have this concentration coming down. And one note, why is it going down? Because we reached net zero, I think. If we go look at emissions and removals, it's like a bathtub. CO2 concentration is all the water in the bathtub. This red line is what's going into the bathtub, filling it up. CO2 removals into plants, into oceans, into soils. There in 2040, they equal each other, dynamic equilibrium. And then at this point, the emissions are below removals. You have a bathtub with more flowing out than in, therefore CO2 concentration is going down. One effect of that is that crop nutrients heal a little bit. Okay, what did we just see? We saw some amazing impacts, including another one I wanted to show that makes me smile every time, air pollution getting so much better. PM 2.5 emissions of those little particles that in New Delhi, in Cleveland, where I was growing up, Ohio, in Beijing, air quality problems, little particles that cause cardiovascular disease and others. Okay, I'll pull up another good news impact. So, what did we just see? There was no one thing. Carbon price didn't do it. Phasing out fossil fuels didn't do it. Methane, food. It takes many actions across this system at many different levels, from individual to family to city, business, state, province, country, corporation, global, many different scales. And it's still possible to bend these curves. It is still possible to do so much better. Now, I've been talking pretty intensely at you for a while. I'm actually going to be silent for 60 seconds. And I'd like you to think, what would you love about being part of a world on track to making something like this happen? What would you really love for yourself? You just like, I love this. Imagine yourself part of a world on track to making something like this happen. Think about that question in silence. I'm going to time it for 60 seconds. All right, that was a minute. Go to the poll, please. Go to the poll. What would you love? Please share something. Nature rebounding. We saw a little bit of that. Peace and accomplishment. Give future generations hope, peace of mind. Thank you. There is a future 7 generations into the future. Seeing civilization advance by leaps and bounds instead of destruction of it. Clean air. Thank you. Less worry. What is the emotional health, mental health impact of not even achieving that 50 years out, but being on track? People thinking about something other than themselves, clean air, a future. These are great. Collaboration, collaboration. Looking forward to a livable future. Thank you. I would feel like we have finally shown respect for the plants and the animals that we share this earth with. Incredibly grateful to all people causing all of these amazing improvements. Being able to breathe, mankind coming together. Equity, well said. Equity. Future generations enjoying a peaceful environment, leaving a better place for future generations. These are wonderful. A return to harmonious and stable cycle where nutrients are recycled, feeling hopeful for the future. These are good. Tell me, where we started out looking at a future where we do very little, you experimented with actions to see how it would affect nutrients, malaria and dengue. You affected drought, and then thought about what it meant to you. Thinking about what you can do, answer this question. I am blank about climate change. Determined, hopeful, excited, more hopeful. Okay. If you see a word you like, make it bigger. Cautiously optimistic, more empowered, motivated, great, determined, resolved, excited, more empowered, still worried, still worried. I get it. I get it. Still worried. Did what I could with what I had. Did what I could with what I had. All right. Well said. If you want two words together, put a hyphen between them. Every day hopeful. Every day hopeful. These are fantastic. Okay. Wonderful. Now, why we're here is we wanted to engage you on these issues, but really it's about what you're going to do about it. And so there, with most of you, there's probably things that you can do in your worlds. The offer that we make as well is that the workshop you just went through, we can train you to go run for your friends, family, president, boss, colleagues, whomever. And we're thrilled that a lot of people, well, 1.5 million people have now used the model in the 21 languages, and they've registered this almost, well, we're almost at 10,000 events in 161 countries with 3,000 facilitators and 300,000 participants. So you can go here and see in this area of China, 9 people. Who are these people? Kowloon Lee played the game right there. No, that wasn't China. So in all these places around the world, we can go and see. Oh, yes, it was. Okay, you can go see. So our offer is go learn how to lead this. And how to do that? We have a free training program called Mastering En-ROADS. Ava, would you post the link to the training program? You can learn how to run the workshop. You can learn how to run the game that we have, a role-playing game that I lead for my students when I engage them, but it's been used in business and other places. And we also, if you're a teacher, just have a homework exercise that students can do out here. That's our offers. We have these things, but maybe there's something else that you think you would like to do about all this. Oh, that's not the poll I want. Excuse me. So, what actions? So what are you going to do about it? What actions are you going to take in the world? And please keep writing any questions in Q&A. We're going to address many of them at the top of the hour. You're going to educate the youth. Wonderful. Tell people about this simulator. Great. Support vegetarian. You saw it matters to methane. It also, vegetarianism leads to less cutting down trees to feed cows, to feed people. So they have more natural carbon removal. Play the game at Earth Day. Educate business school students. Work up to making presentations. Start the course next week. Great. Share the model with members of your climate activist team. Research and disseminate information. Research and participation. Course for community activity. Evangelize. Create alliances. Environment restoration. Plant trees. World needs more trees. Teach understanding climate change course to high school students. Teach teachers how to teach about climate change. I love presenting this to high schools. They eat this up. Just give them the model, let them play. Integrate En-ROADS into a curriculum. Reach out to schools and Rotary clubs for presentations. Work with local electeds and your representatives. Educate everyone around. Contribute to reducing impact. Run the workshop for town planning. Educate coworkers. Demand action from politicians. Educate. Wonderful. Educate the local communities. This is great. All right. We have Peter here for a few more minutes, and I want to direct those particular Q&A questions to him that are about his map. Ava, did you see any that were distinct or that you saw that came up that we could have the professional help us with? I'm also just so interested in his answers to things. Um, did you see any questions? Or Peter, did you see any? I assume you can look in chat if you want to.
So far, I'm not seeing. I will scroll.
Okay, this is your chance, everybody. You've got an expert on this kind of mapping. And so in the webinar chat, any particular questions there, or then we'll shift over to other questions. Denise says that subject to climate.org has a ready-to-use En-ROADS lesson. I didn't know that. That's great.
I see a question from Charlotte. Can you please explain the ranges of likely outcomes shown in these maps? How are these projections generated?
How were
Yeah.
they generated? Cool. Yeah, Peter.
Yeah, absolutely. Great question. So the ranges of outcomes, likely ranges of outcomes. Where's the question?
Well, I think he said,
Yes.
how did you generate them? And I was starting to look here to you have that list of all the cool models and like how you did it.
Yeah. So these models come from scientists around the world that have been building climate models for a long time. And so these are actually not new models. They're well tested, well established. And as the world has begun to change, they actually have been shown to be very reliable in the ways that they predict changes all around the world. The world has now warmed almost 1.5 degrees of warming. The last 2 years were 1.5 above pre-industrial. And so that change that has already happened has shown that these models are very reliable. So what the models do is they actually simulate the climate all around the world. This is a visualization showing the way that simulation happens by dividing the world up into these little cubes in this simulator. And then within these cubes, you can see what the climate would be in certain scenarios. And so on the Probable Futures website or through En-ROADS, you can see that there are 6 different scenarios of different levels of warming, from 0.5 degrees of warming, which is in the past, that occurred between 1971 and 2000, all the way up to 3 degrees of warming, which we could expect around the 2060s at the current rate of warming. And so within each of those little simulated squares, you may wonder, what am I seeing that's actually in there? And it's actually really cool that you can see not just one number, but you can see a range of expected outcomes within each of those squares. That I think you have to go to the Probable Futures website to see. But if you actually click on those individual squares, you can see that in any given year, there is a range of expected outcomes. And what does that mean? Well, if you think about the place where you live, each year is different. You have years that are warmer and years that are drier and years that are wetter. And that range, yeah, that's a great example there. So you see, you have a cooler year where you have 222 days above 90 degrees Fahrenheit or 32 degrees Celsius. And in a warmer year, you have 338 days above 90. And so it shows you that there's this shifting range of expected weather, and that is shifting as the climate warms. And so you can use that to make decisions about what kinds of systems do we have that depend on the past range, and how can we adapt to live well within that future range.
Cool. So you can use 3 of the maps in En-ROADS and many, many more with a lot more precision and other information and some like really great reading of background over at Probable Futures. I want to step back. We're 3 minutes before the top of the hour, the official end of this, and I just want to kind of remind us of the journey that we just took together. When we came in, I asked you how you were about climate change, and remember that sensation of worried, concerned. Then we started looking at good reasons. If we do very little, we saw what will happen with drought around the world, with malaria and dengue exposure, a major public health problem. And then third, with crop nutrition. And I challenge you to think about the kinds of actions that would be needed to address climate change. There was no one thing that we're fighting for. There are many actions that are needed. Now, I didn't point it out, but there are many things that are lower leverage and higher leverage. That's for another webinar, is making that distinction. But we saw that there were many actions that were needed. And when you put it together, we can bend the curve to prevent a lot of the challenges we face.
I would add in another prompt there if I could. What are some of the ways of organizing that might be different from the way we already organize that might lead to some of those actions? That could be another prompt to think about.
Cool. So where we went next was seeing how much better it could be, how much you would love to be part of that kind of world, and then some actions that you yourself could take in order to make it happen. And a little check-in at the end of how you feel after thinking differently about the future and getting ready for what's coming, preventing all that we can. So it's the top of the hour. We're going to stick around for more detailed questions after this, but this is the time when you get to, no shame, sign off, say goodbye, and end this webinar. So overall, dealing with what's coming, preventing what we can prevent, it's not going to be easy. It's going to be worth it, everybody. Go get them. Bye-bye.
Thank you, Drew. This was great.